Now question number 7 is, let x naught greater than 0 and xn be defined recursively by xn equals under root of 6 plus xn minus 1, where n is greater than or equal to 1, then this limit n tends to infinite xn is. Now we can write this xn as under root of 6 plus xn minus 1. We can write this as xn square, it will be 6 plus xn minus 1. Now what we'll do is we'll subtract xn minus 1 square from it. So it will be xn square minus xn minus 1 whole square, and if we take minus common here, we'll get xn minus 1 square minus xn minus 1 minus 6, and if we factorize it, we can write this as xn minus 1 minus 3 and xn minus 1 plus 2. Now here critical points are 3n minus 2, and since x naught is greater than 0, we'll take two cases. Case 1, if x naught is less than 3, and case 2, if x naught is greater than 3. Now if x naught is less than 3, then if we add 6, we'll write 6 plus x naught will be less than 9. That is under root of 6 plus x naught will be less than 3. We can write x1 will be less than 3, and using same iteration we can write xn will be less than 3. Then in that case this function will be bounded above. Now if xn is less than 3, then this value will be negative, this value will be positive, and then we have this minus sign here, so it will be minus and minus plus. So we can write xn square minus xn minus 1 square, and it will be greater than 0, that is xn is greater than xn minus 1. That is, the sequence is monotonic increasing. So if the sequence is bounded above and increasing, that means this sequence, it is going to converge. Now what about the second case? And the second case, when x naught is greater than 3, if we add 6, we'll get 6 plus x naught will be greater than 9 under root of 6 plus x naught will be greater than 3, that is x1 is greater than 3. If we add 6, again if we take square root, we'll get x2 greater than 3. So from here we'll get this xn, it should be greater than 3. So in this case it is bounded below. Now if xn is greater than 3, then this expression will be positive, this is also positive, and here we have this minus sign. So we'll get xn square minus xn minus 1 square, it should be less than 0, that is xn, it should be less than xn minus 1. That means this sequence is now a decreasing sequence. So if the sequence is bounded below and monotonic decreasing, that means this sequence, it will converge. Now what about if x naught is 3? If x naught is 3, then this sequence will be a constant sequence, and we know that a constant sequence is a convergent sequence. So this sequence will be convergent for all the possible values of x naught. Now we'll need to find this limit n tends to infinite xn. For that, what we'll do is we'll take this limit n tends to infinite both sides. Now suppose this limit is L. So we can write L equals under root of 6 plus L, that is L square minus L minus 6 equals 0. That is, the value of L is either 3 or the value of L is minus 2. Now since this sequence, it contains positive terms, its limit point cannot be negative. So for the sequence, the value of this limit is simply 3. So this limit n tends to infinite xn will be 3, and which is none of the above, option D.